Stoichiometry mass problems. This is similar to what we were doing in the last worksheet, except that now rather than asking how many moles of something would be formed from a number of moles of something else, it's going to ask how many grams of a substance are produced if we use a certain number of grams of another substance. Now what we just saw on our last worksheet in the mole-to-mole problems is that if we know how many moles of one substance we have, we can figure out how many moles of another substance would react with it or be produced. We can do this with moles because we know that these numbers, these coefficients in front in a balanced equation, can represent the number of moles of a substance in a reaction. What we can't do, unfortunately, we cannot compare the same way with grams because different elements are going to have different masses, as we know from the periodic table. If I have one hydrogen atom, I have a mass of 1.008. If I have one lithium atom, I have a mass of 6.941. And of course, all of them are very different. So I cannot compare the number of grams to figure out how many of each atom I have. I can only compare number of atoms to number of atoms, which you do when you are comparing moles to moles, because one mole of a substance is the same number of atoms as a mole of another substance. Or I should say, a mole of a substance is the same number of molecules or compounds or atoms, depending on what we're comparing. So this says if I have 2 moles of KClO3, it will decompose, because I only have one compound here, it'll decompose into 2 moles of KCl and 3 moles of O2. So I cannot compare grams to grams here. I can only compare moles to moles like we did in our last paper. So what we're going to have to do is turn our grams into moles and then compare moles to moles. So in order to do that, I need to remember what I was doing earlier on in the packet back here with the moles and mass problems. So remember, if we knew the number of grams of a substance, we could then figure out how many moles of it we had. So that's our first step, is to figure out how many moles of a substance do we have. At that point, we can then compare how many moles of that we have to how many moles of the other substance we would need or produce in the reaction. You'd think that's enough to do. Unfortunately, at that point, it's going to ask us not how many moles of the substance are produced, but how many grams of the substance are produced. So now that we've compared our moles to moles, and now I'll find out how many moles of the other substance I need, I then have to turn those moles back into grams, just like we did on our moles and mass worksheet that I was just showing you a moment ago. So I'm going to turn my grams into moles, then compare moles to moles, and my last step is to turn my moles back into grams. I'm going to do a problem with you here so you can see exactly how it works, and then hopefully you'll be able to do some of these on your own just following this example. So this says how many grams of potassium chloride are produced if 25 grams of potassium chlorate decompose. So my given is always my number. So here's 25 grams potassium chlorate. Here's potassium chlorate. Potassium bonded with ClO3, which is chlorate. So I'm going to write down my given. 25 grams of KClO3, which is potassium chlorate. And I'm going to start my crosshatch here. Remember, I don't write anything down here because it's understood to be 1. Now if I have grams of KClO3 on top, that means I need to have grams of KClO3 on bottom so that they'll cancel out. And this will be, what I put here, will be the number of grams that are in 1 mole of KClO3. Because remember, it's just like I did on these problems. I need to figure out how many grams are in a mole so that I know how many moles I'm starting with. How do I do that? I need to add up the masses of K, Cl, and 3 O's. So I'm going to do that with my calculator. So I'm going to have the mass of K, 39.098, plus the mass of Cl, which is 35.453, plus my mass of 3 O's, which would be 3 times 15.999. And what I get is 122.548 grams of KClO3 in 1 mole of that substance. Am I done? No. All I've done is figured out how many moles of potassium chlorate I have. At this point, I can now that I know how many moles of my given substance I have, now that I know the number of moles, I can now compare moles to moles, and that's our second step. So our first step, I'm going to take my grams and turn it into moles. My second step, I can then compare my moles to moles like I did in the last worksheet. So I have moles of KClO3 on top. I'm going to put moles of KClO3 on bottom. And in my reaction, I have 2 moles of KClO3, so I'm going to put a 2 here. 2 moles KClO3. What am I comparing this to? Well, it asks me how many grams of potassium chloride are produced. So I need to put the number of moles of potassium chloride, which is right here, 2 KCl. So I have 2 moles of KCl that would be produced if I had 2 moles of KClO3. I'm not done. I still have one last step, because at this point what I've figured out is how many moles of KCl I'm going to have, because my grams of KClO3 have canceled out, my moles of KClO3 have canceled out, and now I'm at moles of KCl. But I need grams of KCl, potassium chloride. So I know that if I had 1 mole of KCl, I would have its mass in grams. So I'm going to add up K and Cl again. Actually, what I'm going to do in order to do that is just get rid of my O3 here. And my mass would be 74.551 grams of KCl would be in 1 mole of KCl. So in my last step, I turn my moles back into grams. You do not need to write this part down here when you do yours on these other problems. This is just a reminder to you of what you're doing in each step. Take your grams and turn them into moles. Then you can compare your moles to moles from the balanced equation, and then you can figure out your moles back to grams by finding the mass of the other substance that you're looking for. At this point, you're not quite done. There's one last thing you need to do, and it's the math involved here. We know that we multiply across the top and divide by the bottom. Now you can plug this in as 25 times 1 times 2 times 74.551, and then in the calculator say divided by 122.548 divided by 2 divided by 1 and get your answer. Or what most people prefer to do in what I've seen is multiply across the top, get that number, multiply across the bottom, get that number, and then divide the 2. So that's what I'm going to do here. I'm going to take my 74.551 that I just got times all these others times 2, times 2 times 1 times 25, and I get 3727.55, and then I do the same thing across the bottom, 122.548 times 2 times 1, but times 1 will still give me the same thing I had, and I get 245.096. Then I can divide these two, 3727.55 divided by the answer I just got, and I get 15.21 grams of KCl, because moles of KCl canceled out, and this is the unit I'm left with, grams of KCl as my answer. I know that is a lot of steps, but the more you do this, the more you're going to get used to it. And this packet and the next two after it all use this stoichiometry process. So remember, take your given, turn it into moles. Then compare your moles to moles for what you're given and what you're trying to find in the second step. And in your last step, turn the moles that you just got back into grams of this other substance. Multiply across the top and bottom and divide, and you'll get your answer. So try this next one on your own. Use this as a model for yourself. And if you're still having problems with it, please make sure you come ask. Oh, also, one last thing I should tell you is that the end of your packet says practice that's optional. This is the case. You do not have to do all of these problems. If you do these 1 through 5 and you feel like you really understand the process and you're not getting stuck on it, then you are done with the packet. However, if you feel like you still need more practice with this before you can pass your test on it, then go ahead and do some of these problems until you feel like you have all the steps memorized and you're comfortable with how to do it. But if you do have more questions, please come ask.